Okay, question 7. We've got a question about momentum. So, get my formula. Magic puking vampire. We know momentum equals mass times velocity. So that's kilograms multiplied by meters per second, because obviously we can just remove that multiply sign. So we're after kilogram meters per second, which is A. Students investigate conservation of momentum. So this is the idea that momentum at the start is equal to the momentum at the end. A card is added to the trolley. Okay, so that gives us a clue that we're going to be using light gates, and that gives us velocity. So I'll just tick that off here. The next part is it tells us that they're identical trolleys. So I need their mass, so I'm going to need a balance. Perfect. Now I've got the two factors that I need. It says describe an investigation the students could carry out to show that it's conserved. Okay, so we've got two trucks. Let's go through the basics. Let's have that is stationary. We've got sticky pads so that they join together, and then we're going to push this along with a given mass and a given velocity. After that, so this one's got momentum. We know that this momentum will be shared by the total mass of the trucks. So if I put this here, so total mass divided by the momentum, that would give us the velocity afterwards. So what we're trying to say is the momentum of this will be shared between the total mass of the two. We've just got to put that into sentences. So if I just delete this, just so that my words aren't messed up. So measure the mass of the two trolleys using a balance. Mark. Use a light gate to measure the speed of. Now I'm just going to get rid of all of this so that I go more slowly through it. So there's our light gate ready. And we've measured their mass. So we've done that. So we want to measure the speed of V. So let's put another light gate here. Then once they've collided, we want the speed. So I'm just going to put velocity of trolley A. I'm going to measure that. And afterwards, through the light gate, I want the velocity of A and B stuck together. That's really hard to word, and that's my best way of wording it. So use in fact, that really should say use light gates to measure the velocity of A, and then A and B stuck together after the collision. So the momentum at the start must be just this thing. I've kept this one stationary. So is going to be MA times VA. The momentum at the end must be the mass of A and B together times by the velocity of A and B together, and they should be the same. So momentum is conserved if momentum at the start, A times mass A times velocity A equals the mass is of A plus B times the velocity of A plus B. And what we'll see is the mass of A and B has gone together, has gone up, but because of this, the velocity of A and B will be less, but the product of the two will be the same. Next one, give a reason for the runway being a slope. We just want to overcome friction. I want it so that the trolley A can move at a constant speed. I don't want it slowing down, so we're going to adjust this so it goes at constant speed all the way along that track. Otherwise, the practical, I don't want it accelerating, I don't want it decelerating, so I'm just going to overcome friction. So to cancel the effect of friction so that trolley A has a constant speed. Next part, we've got a tennis racket and a ball. We've got some velocities, some masses, and it asks us to use this equation. So it's just, can we plug these things in? So we're going to need the mass is 0.075. It's traveling towards this velocity. So that's going to be the initial. It hits back at 15. And if I wanted to, I could put that to minus 15. So I'm now going to set this as it comes in at positive plus 2 and leaves at minus 15. If I wanted to, I could reverse these, and all it would do is change the overall answer at the end in terms of positive or negative. And you would still get the marks. So I wouldn't stress too much about the positive and negative. But if I set that as the incoming, I'll have that as positive, and we'll have the outward going one as minus. So now we can plug these things in. So we want MV, 0.075 is the mass, multiplied by minus 15, it moves away. Then I want to minus 0.075 times 8.2. You can see we've left that positive. That was it came in at this, so you must be going away afterwards. All divided by 12 milliseconds. And you had to divide that by 1,000, and that they use that all the time. Milliseconds is used so often. Once we've done that, we just plug the values into our calculator. Try to remember to use that on your calculator. I can't remember. I think the top one is full. I can't remember. I haven't got a calculator in front of me. So we end up with minus 150 newtons because that gives us that reaction force. So I hope that will make sense. Next one, describe how Newton's third law of motion applies to the collision between the racket and the ball. So let's state Newton's third law of motion. For every action, there is an equal and opposite reaction. But then the next part, we've got to talk about the racket and the ball. I'm going to use the word bat because when I had racket, it didn't fit in the lines. So you've now got to say, so the force of the bat or the racket on the ball is equal in size and opposite in direction to the force of the ball on the bat. And you can see I've underlined the bit. We're going to talk about racket on ball, ball on racket, equal in size, opposite in direction. Tricky question. Takes a bit of practice, but with loads of practice, you'll find these easy.